Hey everyone, welcome back to my uncles. In our last episode, we saw how to implement machine learning on cloud platform, where we understood the basics of Databricks and Apache Spark. We used Apache Spark to implement the basic data transformation as well as creating our classification machine learning model. If you watched this video where we tried to see how to classify whether a transaction is fraud or not, congratulations. If not, you can watch that video or you can continue with this video and watch that video later on. Regardless of that, in today's video, we are going to talk about the Financial Transaction Dataset. Again, with another analysis on some another cloud platform. If you watched the other videos that I have uploaded so far, they really didn't touched any cloud platform other than Databricks, where we saw how to implement experiment tracking using MLflow and integrate it with DexApp. And also, Databricks provides its own experiment tracking service, which you can test on Databricks platform itself. We saw both of those things, and now we are at the stage where we need to touch any other cloud platform. And so for this video, we are going to create a machine learning model that will help us identify what should be the credit limit set to a card that is assigned to a user. So suppose a new user is coming to the bank and he's asking for a Visa card of type credit. Then we want to set a credit limit for that card. So how we can do that on the basis of our existing card data that we have? So that is what we are going to do in this video. It's a regression analysis problem. It's going to be pretty basic, but what is not going to be basic is that we are going to do all of these things in the everyone's favorite cloud platform, AWS. Now, the reason I've chosen AWS is probably because it's popular, but also because it provides a lot of services and integration possibilities in the future. Note one thing, that AWS is not free, but for this video, it will not cost you more than $2 or $3 or around 300 INR if you are from India. So you can watch this video and you can pretty much do everything that I'm doing and it will not cost you a lot. But still, if you are someone like me, because first time when I heard about AWS, I didn't try to touch that, because from the person I heard about AWS, he was continuously scaring everyone in the class that AWS can cost a lot of money, you have to be careful. And that's just not the full truth. The full truth is that AWS will cost you money because it's a cloud platform. And there are two types of cloud platform. We already talked about Databricks, where we get the community version, which is always going to be free to use. And it will automatically shut its cluster once we create those clusters. So after every 2 hours, the clusters will be automatically terminated. But that is not the case with AWS. AWS will set charges for those things that you are using, and you have to pay that. But this is not like you are not aware of what things you are using. So until or unless you are someone who is completely out of mind or someone who is not regular on these kind of things, so you are like, if you're watching this video right now and then you skip in between and you start watching after 1 month, in that case, I would not recommend you to watch this video for the first. And the second would be, even if you watch this video, make notes. Don't try to create your AWS account or work with me with AWS as this video is proceeding. So the thing is that AWS is not going to cost a lot. As I've told you earlier also, hardly $2 or $3. But if you leave things running, then it might cost you some money to pay, which you have to eventually pay. And in the starting as well, you have to put your card details in the AWS for your account creation. And when I first about AWS, I used my friend's card because I didn't had any Visa or MasterCard that time. I hope you have your card, but if you are in the boat which I was once, it's completely fine. You can take your friend's card who is rich enough to have those Visa and MasterCard, or you can watch this video. And in the future, once you get your own card or maybe someone's card, you can start performing the analysis by your side. Regardless of that, I assume that you are eligible enough to create your card and you are having that potential to watch this video in a period of 3 to 4 days. And also I will tell you, even if you are not watching this video, then how can you save your charges by deleting or terminating the instance that we are going to create. Although we are not going to create instance, but still I will tell you what you need to delete in order to save the charges that may cause because of your mistake or maybe your not proper handling of the cloud platform. So yeah, with that note, let's begin this video. And we are going to talk about today's main shiner would be Amazon SageMaker. Now, Amazon SageMaker is now different. We are going to talk about Amazon SageMaker AI because Amazon SageMaker is now a wrapper which contains Amazon SageMaker AI, Amazon Bedrock. Now, what is Amazon Bedrock? Amazon Bedrock is for generative AI kind of projects, which we are going to touch in the future for this series itself. And what I'm planning is I'm planning to upload a video around Pydantic AI in the future as well, teaching everyone how to use LangChain and the Pydantic AI to work with the RAG. I'm currently studying LightRag, which is a great tool to be honest, but I will not explain more about that in this video. So yeah, there is a lot of scope that we can do on the AWS SageMaker. But for this video, we are going to only talk about Amazon SageMaker AI, which is a part under this big umbrella, which is Amazon SageMaker. So in Amazon SageMaker AI, we are going to see everything from starting to end, a complete project you can show in your resume as well. But before that, I also want to tell you that why Amazon decided to give the name to the platform or to the service as SageMaker. Now, even I was not aware about this and I was not even able to pronounce this correctly. So one of my great mentor, Mr. Vikas Das, explained me the story about SageMaker and I would love to tell you as well. By the way, Vikas Das is a great MLOps teacher right now on the YouTube. I will also provide his link of the channel in the description. You can watch his videos for MLOps. If you prefer to study in Hindi, his content is just a god level content, which is unmatchable with any other content on the YouTube. Regardless of that, what we are going to see is what is Amazon SageMaker, why we have given this name as SageMaker, or why Amazon have given this name as SageMaker. So earlier when foreigners used to visit India, there are some priests in India. We call it as sadhus over there. So those people were basically the future predictors. So they used to predict the future of the person. So from them, after watching those people, the foreigners decided to call them SageMaker, the future predictors. So they used to call them sagers basically. So from that word sager, Amazon decided to use it because over here on the SageMaker, we are doing the same. We are trying to create the models which predicts the future. So that is why Amazon decided to name the platform as Amazon SageMaker. So yeah, that was it for the introduction part. Now let's look at the data set. If you are someone who is watching this video series for the first time, you have to watch the dataset analysis. If you are someone who has already watched the data understanding, what is our datasets? If you are someone who knows about the dataset, you can skip this part and you can start from the part where I show you how to create your own, I would say, AWS account, and then starting with the Amazon SageMaker. Since in our previous two videos, we have already discussed about users and cards dataset, but still, I assume that you are someone new. And also for my previous users who watched the first two episodes, I want to make sure that they also understand the dataset completely. And for that, we are going to look at our dataset for the final time, but this time we are going to cover up everything to understand the dataset. So I will start by first explaining you what this dataset is having to offer us. You can scroll down and you can see over here. This is a comprehensive financial dataset, combines transaction records, the customer information, and the card data from the banking institution. Although this card data is not correct, so don't try to use it. Spanning across the 2010s decade. That means it is 10 years old dataset. And one more thing I want to add on to this dataset is a synthetic dataset. That means it was generated as a fake dataset. We can do that in Python. We can generate fake dataset. Apart from that, we have the dataset is designed for multiple analytical purposes, from synthetic fraud detection to customer behavior analysis and expense forecasting. Since we are already working with the first analysis, which is going to be the fraud detection analysis, so we are going to look into that. And then in the upcoming videos, as I have discussed in the starting of this video, that we are going to make the customer behavior analysis, which is basically customer segmentation, as well as some other projects around it with Gen AI as well. Okay, so let's see the 5 files that we have over here. We have the transaction files. Transactions data.csv is going to have 1.33 lakh transaction. That means not 1.33 lakh, 1 crore 33 lakh transaction. It's like 13 million transaction. Okay, so 13 million is not a small number. We are not going to analyze the complete transactions.csv file because again 1.2 gigabytes of file to analyze will take at least half an hour to run the code. And as I've told you earlier, we are going to use Databricks for this video. Running this much size of file on the cloud will obviously take more time, and it's not a reliable case for the video. Although we'll understand this file completely, still what we will do is we will segment this file into 4 card types, that is MasterCard, Visa card, MX card, and Discover card. We'll talk about that in this video only, but after some time. For now, let's just look what this file has to offer us. So this is a transactions data file. Over here we have, let me come down. You can see we can select the transactions data.csv. And this file is having the amount, timestamp, and the merchant detail. Now over here, merchant ID is something new. So let me show you. We have a ID, which is a unique ID for each transaction in this dataset. In total, we have 1 crore 33 lakh transaction, or I would say 13 million transaction. So this is a unique ID for all those transactions in my transactions data.csv file. After that, we have date and time of the transaction. As you can see over here, we have the client ID, the client who is doing our transaction. In total, in our dataset, we have 2000 unique clients. So this is the client ID for all those unique users, starting from, I guess, 0 or 1 to 2000 as a client ID. So our client ID will be between 0 to 2000, or like from 1 to 2000, or 0 to 1999. I'm not sure about it, but yeah, it's we have 2000 unique clients in our dataset. So for each client, we have multiple cards. So in total, the number of cards that we have in this dataset, the unique cards, are 6146, and these are my cards ID, which is a unique ID for each card. So in this dataset, we have the transaction ID, the date, and the client who is doing the transaction, and the card ID is the card ID from which he is making the transaction. The amount is the amount he is making in the transaction. Then we have this use chip, which is a value to say whether a transaction was a swipe transaction or a chip transaction or an online transaction. So this is again a categorical variable that we have. We have merchant ID, which is for merchants. Now this is again not a unique ID, but still we don't know the merchant ID. Like we just know the merchant ID. We don't know anything else about the merchant. Although we do know the merchant city and merchant state, but apart from that, we don't know anything else. We have zip as well, which is the zip code of the area where the merchant is living. And then we have the other two variables, which is for the error. You don't have to look at this. Just ignore the error right now. For the MCC code. Now, let me explain you what is the MCC code. All of the card brands like MasterCard, Visa, MX card, or Discover card, they are having a unique ID for each type of transaction. Suppose you and your friend are going to a restaurant and your friend pays with his card, and you are going to a restaurant. So while that transaction is being stored at the servers of MasterCard, they will assign a unique ID to the business, and that ID is my MCC code. So to all transactions like restaurants, we are assigning a unique value, which is my MCC code, to that kind of transaction. So all kinds of transaction related to restaurants will have a different MCC code. All kinds of transaction related to a car purchasing or a bike purchasing or a vehicle purchasing will have a different MCC code. Suppose you are going to a healthcare service, over there you used your card, so there it will be a different MCC code. So to each industry or to each service that are possibly available right now, we assign a different MCC code to that, just to track what kind of transaction the users are making. And using this MCC code only, in future we are going to perform the customer segmentation so that we can run the campaign only to those potential users who can take the advantage of that campaign and ultimately generate profit for our brand. Okay, so MCC code is really useful. For this dataset, we have only 188 or 189 unique MCC code. That means the transaction is like the all transactions that we have, 1 crore 33 lakh transactions that we have, are done for 188 unique type of businesses, where the merchandisee is given, the merchant state and city is given, and the zip code is given as well. Yeah, so this was all about the transactions data. Now let's look at this client ID. Client ID is basically the user's data, where I have ID as my client ID. So let's move on to the users data.csv file. Let me select this. To get all the columns available, you just have to do it. I don't know why they have added it, but maybe for a very large data set where we have thousands of columns, they don't want you to see all the columns and load all the columns. So that's why they have probably done it. Kaggle, that was really a nice job, but still not of our use for the dataset having only 14 columns. Still, let's look at this users data.csv file. This will contain the data about our users. In total, in our dataset, which is my financial transactions dataset, in our bank, we have only 2000 unique users. So this ID will be from 0. Okay, so it's from 0 to 1999. So there is total 2000 unique users. We have the current age of the users, which is not updated. But since this dataset is of like 7 years ago, it was last updated. So we'll consider this current age as the current age only for the analysis purpose. We have retirement age, we have birth year, we have birth month, we have gender, we have address, we have latitude, longitude, value, from which we can calculate the exact location of the user. We have per capita income, which is like a family total income. So suppose, let me explain you what is per capita income. Suppose you are living in your family of 5. So you are only earning. So you have a earning of $1 lakh or 1 lakh rupees or maybe any other currency. So you are living in a family of 5. So your per capita income will not be 1 lakh. It will be $20,000. Though your yearly income, which is over here, is going to be equivalent to 1 lakh. So this is what the difference between per capita income and the yearly income, which can be a good predictor for a lot of analysis, which we will consider in the further episodes. We have total debt, which is the debt taken by our user. We have credit score, which is the credit score of our user. And the number of credit card defines to how many unique cards do my user have. So you also can have more than one cards. So in this dataset also, we have 2000 users and they can have multiple cards with them. So now let's talk about cards, because we right now only talked about cards. So you can see this is my client ID and it will work as a foreign key in my transactions dataset. So in my transaction dataset, we have the client ID over here. So foreign key is basically from this client ID, you can access to any detail of the user by coming back to the user's dataset. So let's say for the client ID, here we have 561. So for 561, in this dataset, we can't see what is the current age of this client. But if you go back to the users dataset, over here we can see the current age of the client having the ID as 516, although I can't see it over here. But if you scroll down, you'll get the 516 user. Or we can just arrange it in this ascending order. Not needed, but still, I just want to show the curious users that I have. I'm not gonna scroll till 500 values, guys. Check it by yourself. Okay, so after that, let's talk about the cards dataset. Now, this card dataset is also having a unique ID, which is a unique ID for the card, and the client ID, which is my client over here in the user dataset. This is my ID. So this ID and this client ID are basically the same. Here, my client ID is working as a foreign key, referring to this user's data table. I hope you know the basics of SQL. If not, understand it in a way that over here, I'm not giving all details of user. I'm just giving the user ID of the user. And if you want to check more details about the user, you can basically go to this dataset. And for the specific client ID, you can check the other details. Like for 825, we can see the current age is 53, the retirement age is 66, and so on. So in the cards dataset, we have card brand, card type, which is the debit, credit, or debit prepaid. We have card brands. In total, we have 4 card brands, which is MasterCard, Visa, Amex, and Discover. We have unique card number, which is also a unique key because every card is going to have a unique card number. We have expiry date for each card. We have CVV number. Although don't try this, it is not gonna work, guys. I've already tried it to check my luck. Okay, just kidding. So this is a synthetic dataset. That's why it will not work. Okay, so it's not a real dataset. We have hash chip value, which is going to tell whether a card is going to have a chip or not. And you can see Kaggle has already created this pie chart showing that almost 89% of our cards are having chip and other 11% are not having chip. We have number of card issued, which will say that single card was issued for 2 times or for 1 times or for 3 times. So it's like the same card, how many times the same card was issued to the user. So, if the card is expired, we are getting the same card again. Or if the card is stolen, we are getting the same card again. So like that, how many cards were issued? So this user got 2 cards. Some users will get 1 card. Some users will get 4 cards. Depends on the user. You can check the values over here. Then we have the last value as credit limit. Although we missed 3 other values. Don't worry. You just have to click on select all. We have the credit limit, which is the credit limit for each card. I hope you know what is credit limit. And if not, then credit limit is the limit of the card. So without paying, you can basically use that limit as your own money. And of course, you have to pay by the end of the month. If you will not, then you will get a heavy interest on that money. So of course, not recommended to those who are not having a stable income. So yeah, then we have the account open date for the user. Last year PIN changed as well. And then we have cards on dark web. This last value is always false, since you can see over here. So in our previous video, what we did was we basically just dropped this column because it was always false. Still, it's a good column to analyze, but although it's of no use because all the values are false. After that, let's talk about the 2 new files which we never discussed before, which is train fraud labels.json and mcc codes.json. Now you can see that in the transactions data, we have this MCC code. So I have already told you that each code will be used to basically distinguish a different business. So in total, we have, I don't know how many unique values, but we have around 180 unique values. So MCC code over here defines to a business. So this MCC code.json is a JSON file which contains what kind of a business that MCC code is having. And in total, we have 109 items. Okay, so we have only 109 or 108 unique businesses for the analysis in this dataset. So we have only 108 unique MCC codes or 109. We'll check that. So you can see over here for 1711 MCC code, it refers to a business that is related to heating, plumbing, air conditioning, or contractor, like all these contractors. Then for 3000, it's for steelworks. For let's say 3144, it's for floor covering stores. And like that, we have these different unique values. For doctors and physicians, we have 8011. For medical services, we have 8099. And like that, we have unique values over here. For barbers over here, I just saw it right now. Okay, for restaurants, you can see it's 85814. And for barbers, I don't see it, although it's gone. I'm not going to waste my time on that. So like that, this file is basically going to have a dictionary kind of structure where we have unique MCC code, and corresponding to that, we have the business that is having that MCC code. So this is given by the credit card brands. Although in real life, I guess that there will be more MCC codes defined by the card brands like MasterCard and Visa. But for this analysis, we are only going to consider this 108 unique MCC codes. And then we have the last file, which is my train fraud labels.json. It's a very big file again, 159.08 MB. Now, let me tell you what this file is going to have. This file will have only two values. The first one will be my transaction ID, and the second one will be a label as yes or no. The name itself suggests that it will tell me whether a transaction is a fraud transaction or not. So it will be having a binary value as yes or no. In our real transaction files, we had 13 million values. But over here, we are only going to have 8.9 million values. That means we don't know what is going to be the values of whether a transaction is fraud or not for the remaining 40 lakh values or 30 lakh values. I guess 40 lakh values, yeah, somewhat around 40 lakh values. We don't know what that transaction is, like it's a fraud transaction or not. But on the other hand, we have 90 lakh values or around 180.89 lakh values, I would say, 8.9 million values. For that, we know that whether that particular transaction ID is a fraud or not. So this is wrong. We have definitely more than 5736 items in this table, in this JSON file, which we will convert into a CSV file just after understanding this file over here. So we can see we have multiple transaction ID over here, along with a label whether the transaction is a fraud transaction or not. So I guess I've took a lot of your time explaining this data set, but it was really important, guys, because what I feel is once you understand the data set, you explore it by yourself, you get that view now to analyze it in a way that it makes sense. So that's why in real world also, we spend more time understanding the data set than actually making machine learning models to it. Because once you understand what your data set has to offer, then and then only you will be able to apply multiple concepts. So after understanding the MCC code, which was for me also something new, because I have never worked in a bank or a card company. So for me, MCC was something new, like, oh, they are checking what kind of a transaction we are making so that they can send us the ads on basis of what our transactions look like what our transactions are based on. Like we are spending more on food, we are spending more on healthcare. So like that, they can send us the offers or something like that, which we can take use of, and even they can generate more revenue. So overall, I hope you enjoyed having a look at this complete data set. So since we are going to work with AWS, we have to create our account on AWS platform. Now, as I have mentioned you earlier as well, you have to give your card details. For example, your Visa card, MasterCard, MX card, or I don't know, there is one more card as well. So once you will pass those details, then only you will be able to create your account. If you don't have your own card, you can take your friend's card or someone else's card in your family as well. But make sure to use that correctly, because if there will be some cost that you might incur for using some service, you have to pay that. So keeping these things in our mind, we are going to create the account in AWS, and then we are going to see some methods to follow in order to be secured or to be safe while using this cloud platform. Although hacking is not something which will happen with you, but still we have to be careful. And I will teach you some basic methods that you always have to keep in your mind when you work with AWS. So over here, the very first thing that I see is Amazon Web Services, which is my AWS. Now you can create your free tier account over here. Now the terms for the free tier and everything, you can go and read and learn about what are the things that you can use. Probably in SageMaker as well. It provides you a lot of free features as well. So you can just check that out on your site. For now, what I'm going to do is I'm going to click on create account to show you what account creation looks like. So the very first thing that I see over here is sign in. So sign in is for those who has already created their account. Right now, if you have created your account, so you are going to either sign in with your root user or IAM user. So what is the difference between root user and IAM user? If you are using it for the first time, the simple explanation would be root user is like your main user ID and password. So here you will pass on your email which you have registered for creating this cloud platform, as well as you can also give your password, and you can add a two-factor authentication or authenticator app, which I'm using to be just safe when you are working with root user. Whereas IAM user is a user that you are going to create in your AWS. So the difference between root user and IAM user is that when you create a root user, you don't create it. It is automatically created once you create your account. And root user, once you log into your root user, you can basically do anything on this platform. But once you make your own IAM user by setting up the username and password for that, IAM user will not have access to your whole cloud platform, and you can assign the services that IAM user can access. So it's like you are creating a platform where you are creating the sub users who can access. So of course, we are not an organization, we are just an individual. But still, for our safety, what we are going to do is we are going to create the account first, and then we will create a IAM user to make sure that we only use the services which we need. So suppose in future, your credentials are being accessed by a hacker or some person who is going to use it for wrong purpose. So in that case, if he gets your root user ID and password, you are going to lose everything. You just have to delete your account in that case. But once you have your IAM user, if someone gets your IAM user's credential, the simplest thing that you can do is delete that particular user only, and you don't have to worry about your account in general. So I hope you understand the difference. Initially, we are going to get the root user details, but then we can create an IAM user, which will allow us to work with all the services. But at the same time, if some person gets our details of IAM user, we can sign in back to the root user and delete that particular IAM user. Okay. So yeah, that's a very small and a good habit that you should take when you are going to work with the cloud platform. There are going to be a lot of other things that you have to keep in your mind, but this is something which I would love to tell you in the starting. Now you have to create an account. So you are going to click on the button below, and it will open up a very beautiful page over here for you. So root user email address will be the email address that you are going to use. And for the account name, you can give any account name. Then you have to click on verify, and then you have to follow the further steps. It will ask for your card details. So make sure that you give your card details. And I hope once you are able to create your account on AWS, you will get your root user and the password for that. Once you are done with that, you can sign in with the root user details over here. So let me sign in very quickly, and then I will show you how the home page of the AWS platform looks like and what we are going to do in this today's session. So now, once you sign in with your root user that you created while creating your AWS account, you will be redirected to a console home like this. Now over here, you can see we have recently visited services. You probably won't see this because you have not visited any services yet. And in the top as well, you can see here it is my account. And just before it, there is something as United States, Ohio. Now, there are a lot of places over here, and these places are basically the data centers that AWS is currently having. and you are going to be connected to the data center which is nearest to your location. Sometimes it connects you with a data set or data center which is not close to you. So you have to cross check that while you are working with services like SageMaker, but still most of the time it will auto connect you with the nearest data center. Regardless of that, as I told you, we are going to first create our user from our root user account, so that even if the hacker gets the access to the IAM user account, we can just easily delete that IAM user. Okay. So the way we are going to do that is pretty simple. All you need to do is you need to just jump over here in the search bar and you need to type in IAM. Once you type in IAM, you can see over here it says that manage access to AWS resource. So we want the user to only access the things which are required, and the organizations uses this a lot. They will not give you the root user details for the cloud platform. They will just give you the IAM user detail, which will be stick to you. The policies will be made in such a way that you will be able to perform your day-to-day task. Suppose you are a machine learning engineer, so for you the policies will be different than a person who is working on maybe a a front end project or maybe a back end project. So basically, they just segregate the users on basis of their requirements and then they set their policies. Okay. Currently, I'm having one user over here, and how to check the user? You just have to click over here and go to the access management. In that, you will get the users over here. So we have users, we have user groups, but as we are going to work on a project which is on our own cloud platform for learning, we are not going to look at the user groups and everything. So what is user group? I can give you an idea. Suppose in a company you are going to work, there are going to be several groups, and there will be a MLOps team. There will be a machine learning engineers team. There will be a backend developers team. So they will be having different access to the cloud platform. So for each group, there will be a different group assigned on the cloud platform as well, and in that group they will be given some policies, or they will be assigned some policies which they can work with. So suppose there is an engineer who is working with in the backend group. What will be his use to work with SageMaker? So he will not get the policy. He will be not assigned the policy of using SageMaker AI, whereas I will be not assigned a policy of using some other services on this cloud platform. So yeah, that's also a benefit of creating a group where we can basically assign the policies for more than one user that we are creating. But to create a user over here, you can see I also have one initial user which I created while I was working with deployment of a Hugging Face model on AWS SageMaker. But as we are going to not do that in this video we are going to create a credit limit predictor for a new user who is coming to our bank, so that we can assign a credit limit to the credit card that we are going to give to that user. And to do so, we have to go to this create user over here, and then we have to assign a name. So we'll assign the name as credit limit SageMaker. Yeah. So this will be the name of our user. You can give any name according to your wish. Now we have this provide user access to Amazon Management Console. Yes, we want to give the access to this Amazon Management Console because I want my user to work with this console over here, which I am working as a root user. Okay. So after clicking on this, there are two things over here. One is specify a user and identity center, which is a good practice for the companies, but as we are individuals, we are not going to worry about this over here, although it is recommended. But we'll just click on I want to create an IAM user, and this is something which we are going to do, and we will auto generate the password over here, or you can assign your custom password as well. You just have to follow the steps over here, and after that it asks for user must create a new password at next sign in recommended. We don't want to create our new password again, although you can do that. It's a good practice, but for now I will just unclick the box over here, and I guess everything else is looking good to me. Now in the next over here, it is telling me to set the permissions for our user. Suppose you are living in a house and you are the owner of the house. or you are living in a hotel and you are owner of the hotel. So you are the root user. Now there are several people in the hotel. Or let's take an example of a bank. Suppose you are the owner of the bank, so you have the access of everything. So you are the root user. There is an accountant who has access to a PC only. There is a group of accountants, so we will call that as group over here. But since we have not created any group yet, so we are not going to worry about that. But just to explain you, we have a group of accountant and a new accountant came to do the job. So for him, the permissions would be to just use the PC. And as you know, to use the PC, we have to attach the permissions of the group, which is of accountant. Okay. So we will attach those permissions with the new user. Whereas suppose a user is a senior manager. So for him, he can access the vault as well. He can access the PCs as well. So for him, the permissions will be different. So his group will be different. So we can attach the policies from the groups that we have. We can add the user to the existing group, or we can attach the policies from the group, copy those permissions that we have for the other groups without adding the user to those groups, or we can customly assign the policies directly. So we will do that over here. Okay. So the reason we are going to do that is we don't have any group, the very first thing. Secondly, we are not an organization, we are just individuals. Okay. So and there are a lot of policies over here. If I type SageMaker, you can see for the SageMaker also. Let me just make it like this. For the SageMaker also, we have a lot of policy over here. So SageMaker, Canvas full access. So what is Canvas? Canvas is like a place where you can no code. Of course, with no code, you can deploy the models. Okay. So without doing a lot of codes. So you just have to like use it without a lot of code writing. And in the end over here, we have SageMaker full access. So suppose you are a lead engineer in your company and you are in a ML group. So you might have this SageMaker full access. And suppose a person is just like creating the model, or maybe a person is just like training the models. So for them, you will give a specific part of the Amazon SageMaker. So for now, we can either click on this, but since we are going to use with multiple services like S3 bucket and everything else, we are not going to click on this Amazon SageMaker full access. Instead of that, we are going to give the administrator access over here to our user. This is not a good practice at all, because by giving this administrator access, user can watch anything. But since we are individuals again, we don't care about what user watches, because in the end, we are going to be that user. So we will not worry about that. So yeah, we will give the administrator access over here instead of setting up policies multiple times as per our requirements. After setting administrator access, user can access almost everything that a root user can access. Now you might ask me a question that if we are assigning this as administrator access, if some hacker gets the credentials of my IAM user, he can easily access all the services on my cloud platform. You are completely right. He can access, but at the same time, you also have the right to delete your IAM user from your root user. So currently we are in our root user console. So we can delete any user that we create. So yeah, that's a very simple step that you need to do. But if someone gets your root user details, you have to basically just delete your AWS account. Okay. So now after clicking on administrator access, and don't worry about a root user as well, you can set up the multi-factor authentication. You can download any authenticator app like Microsoft Authenticator, where every time you have to give OTP in order to sign in. Okay. OTP, whatever you call it. I just forgot. So yeah, over here, we are going to assign it as administrator access, and I'm going to click on the next over here. And now I feel it's almost done. So I'll create the user over here. So once the user is created, you can see I have this console sign in URL. Now I will show you what this is in a second. This is my username and this is my password. Now, of course, I don't know how many watchers I'm going to get for this video, but still, it's not a good practice to show your password and everything. So don't worry, I'm going to delete this user once I complete this video. So yeah, that's the benefit of creating your own user. So as you all know about this user, so I have to delete it, but I will also show you how you can delete any user. And before deleting, you can also download the CSV file over here. So you can see I got this CSV file right over here, which is in my PC. Now in this CSV file, I will show you what this will contain. This will contain the URL, the name, which is my username, and the password which I have. So next time if I try to sign in my AWS cloud, I don't have to sign in with my root user. Instead of that, I can sign in with my IAM user. And if you go to your AWS console over here, if I type AWS, you can see over here, initially, while we try to sign in, of course, I've already signed in, so it will probably not show me anything. It will just show me the home page. I hope it won't. Yeah, it showed me the home page because I've already signed in. Okay. So that's why it just shows like this over here. But you probably, when you try to log out of this particular root user and then you try to sign in, you can sign in with your IAM user as well, which I will just show you. But before that, I will show you how to create your user. Since you can see over here, this is our user which we created. And suppose anyone got the credentials, all you need to do is click over here and delete the particular user by writing the name of the user over here and pressing delete user. That's it. That is all what you need to do. So now again, let's create a new user. And after that, we'll see how to sign in with IAM user. Okay. So over here, this is my CSV file looks like. You can see we have the username over here. We have the password as this random password that we generated using AWS. And in the end, we have this custom URL. So this custom URL is basically our URL, which will directly redirect us to the IAM user login. So what I will do is I will quickly show you how to first log out from our existing root user and then how to sign in using this credentials that we got by creating our first user, or you can call IAM user. So yeah, now what we are going to do is we are going to first log out with our current user and then we are going to sign in with our IAM user. Okay. So let me very quickly go over here and do sign out. As soon as you sign out, you will be redirected to this page over here. And once I click on SageMaker AI, Amazon console, you can see over here, it says that I am sign in user sign in, and it will ask for account ID. So your account ID is basically the number which you see in the console sign in URL link. Or what you can do is you can just copy paste your console sign in URL link from your CSV file that you created. So I will do the same step over here. I will pass that console ID. You will get a different console ID. And this is basically my account ID, which I can copy and paste over here as well. But since we want to directly use it, once I run this, the account ID will be automatically placed over here. And for the IAM user name, I have my username with me. So I will take that name from the CSV file that we downloaded. And similarly for the password, we are going to do the same steps. Now remember one thing, if you have clicked on change password once signed in for the first time, you have to then reassign the password. If not, then you will be just able to click on sign in. Now this time we are signing in IAM user sign in. Okay, this is not root user sign in. So now just click on the sign in. And once you are done with that, this is again the console of AWS, but this time as IAM user. And you will probably not see the cost over here. Okay, or you may be able to see the cost. Regardless of that, this is our IAM user, not our root user. And see, we can't see the cost over here. The access is denied. So from that, you can get an idea that root user is something different, whereas IAM user is something different. Now over here, what I'm going to do is I'm going to quickly just show you the services that are being offered by AWS, which we are going to use. AWS is a very great platform. It's like a black hole. Once you enter, you can't exit. Reason is because there are a lot of services that AWS provides, and once you get used to those services, or once your organization gets used to those services, it is like you will be not able to replace or put it to somewhere else. It's just like you will be stuck to AWS. So we'll just type SageMaker over here, and you can see we are getting two options, which is Amazon SageMaker and Amazon SageMaker AI. So as we discussed before as well, Amazon SageMaker is like an umbrella which is containing the Amazon Bedrock and Amazon SageMaker AI and some other services. So what Amazon is trying to do is, Amazon is creating a unified platform, a unified studio, which is known as Amazon SageMaker, in which we can use all these services. But for now, we are going to focus on Amazon SageMaker AI only. So you have to click over here and you can see we can build, train and deploy machine learning models. Whereas in Amazon Bedrock, we can work with the generative AI projects. So I will click on over here on Amazon SageMaker AI. And as soon as I click over here, it will take some time to load, but you will be redirected to the SageMaker canvas. Okay, it is taking a lot of time, more than expected. And you can see over here, the data center is United States, Ohio. Make sure you are connected with the nearest data center. Again, we are going to create domain over here, but for now, let me just cut this off. We have the domain over here, and what else do we have? We have training, we have interface, which is like endpoints. So I will teach you what this is, but before that, in trainings, we can see the training jobs. And currently, we are having this all training jobs over here, which were completed. Okay, so these training jobs were not done with this current user, because this current user is just created right now. But since we gave the administrator access, we can watch all training jobs done on SageMaker. It doesn't matter whether we did it or someone else did it. Okay, so yeah, this was some training jobs that we did before. But for now, coming back to domains over here, we will create a domain. So for under the administrator configuration, we have to click on this create domain over here. And once you do that, there are two options over here. Either you can set up it for a single user, or you can set up it for an organization. When you do it for a single user, what it will do is, it will give all SageMaker access to the user. You can read over here, new IAM role with all SageMaker full access policy. Whereas over here, you can define what access do you need to give. Since we are not an organization, we are just going to quick setup and click it for a single user. And once we are done with that, we are going to click on this setup over here. It's going to be a pretty basic step. Still make sure that you follow it correctly. Once we are here, it will take some time, and then the domain will be created over here. And once you go to the user profile, a user will also be created. But for now, we'll click on this domain over here and wait till the domain is created. Right now, the status is pending. Once it is created, it will show created over here. So let's wait for that time, and then we will see how our domain look like. And let me just show you. Yeah, so this is how the screen looks like. Okay, let me set up. Yeah. So yeah, let's wait and then look at the domain and the user that the domain has created in it. So guys, once your domain is created and it says that in service, your user will be also created. One more thing to note is that maybe you will still see the status as pending because you have to update your current screen. So just reload it and it will be fine. You will be able to see in service and your domain will be active and running. I don't know why my internet is just like Let me just arrange my photo over here so you see me as well. Okay, so I will click on this domain over here, and inside this domain, maybe my internet is just not working properly. Okay, so you can see over here we have this domain. You don't have to click on submit over here. Make sure. Then we will go to this user profiles, and you will be initially getting a user. Many of you will get the user, but some people like the special ones who the god is like just against them whenever they try to learn something new. So they might not see this user profile. Although AWS has resolved this issue, but if you are the one, you just have to go to this add user and create the user with keeping everything as it is. So you just have to click on next, and then you just have to click on enable ideal shutdown if you want your Jupyter Lab to automatically shut down once you are not using it for a particular amount of time. We'll just keep that as it is. And if you watched my previous video, you know what is ML flow, right? If not, then I would suggest you to watch that video first. And if you want to understand at the very ground level, you can check out the playlist of Vikas Das. He's a great MLOps engineer, though his playlist is in Hindi. But if you are comfortable with that language, you should definitely watch his playlist. Even I learned about this tech from him only. So yeah, a definite recommendation from my side. So yeah, all you need to do is create next and create your user, keeping everything as it is. But right now we are not interested in doing that. So we will go back to the domain that we created, and we already have a user. So we will go to this user, and you can see the launch over here. So what we are going to do is, whenever you try to work with a machine learning project, we create a notebook, a Jupyter notebook. And over here, we are going to do the same. We are going to create a Jupyter environment, just like we do it on our local computer, but this time on cloud. So if I click on this launch over here, it will show me options of Studio, Canvas, TensorBoard, and Profiler. But I worry about Studio. So I will click on this Studio right over here, and this will open up the Amazon SageMaker Studio for me. It will take some time. Again, guys, have some patience. Once it will be done, you will be redirected to this complete new console of SageMaker Studio. Now, I will just click on the skip for now to tour because I will give you the tour. So you just have to go to this Jupyter Lab over here and click on this. You also have R Studio if you are a R learner like me. You love statistics. By the way, I'm doing my master's in applied statistics, so I love R. You just have to go to this Jupyter Lab over here, and in this currently we have no application running. So what we will do is we'll create a Jupyter Lab space. So we'll create a space that we will use in order to execute the Python code. So if I click on this create Jupyter Lab space, I can give any name. I don't want to share this with anyone, so I'll keep it as private. And let's give the name to this notebook as SageMaker AI. I don't know what to give. Just keep it as SageMaker AI. I guess that's already. Oh, we can't give underscore. So we'll just give it as AI. Okay. So then we'll create the space. Now again, this will ask you for the instance, but our instance will be MLT3 medium. So we'll click on that, and we can change the instance as well if you want. Make sure that this will cost you money. Okay. So this was the point where I have to discuss about the money. Till now, you will be not charged anything, but for using MLT3 medium, it will cost you money. To be precise, how much money? So let's check that. ML.T3.medium pricing on AWS SageMaker Jupyter Lab. Let's see what will be the pricing of that. And let's wait for some seconds, and then we will be redirected over here, and you can see pretty much what I see. Okay, so I'll click on SageMaker AI, and then I will click on Jupyter Lab. So in Jupyter Lab, if we try to use this MLT3 medium, just wait for some time. It will load according to your region. We have this MLT3 medium over here. Okay, so what is the pricing for that? The pricing is that it's just $0.5 an hour. And if you don't know what is the conversion of $0.5 in Indian rupees, it would be somewhere around 2 to 3 rupees or 4 rupees, somewhere like that. So yeah, you will get a basic CPU with 2 cores and a 4 gigabytes of memory. And yep, that is it, I guess. And you can check to this as well, to any other as well, if you like. Regardless of that, make sure you check the pricing for some, I would say, systems over here. For some instances, you can see the price is like as high as $5 per hour. So this price is for per hour. You can see price per hour. So make sure you choose the right one. And the best practice would be to choose something that I will tell you to choose. Okay. So since you are watching this video, don't be curious on your side. After watching this video, after completing 1 or 2 projects on your side, then you can basically try other things as well by making sure that you are aware of what instance you are using. Okay. So for some instance, it is going to be less. For some, it is going to be more. When you are using an instance having more power, you will get more compute and it will be faster. Okay. So our initial default would be this, and we'll click on this run space over here. And when we do run space, it will create a Jupyter lab for us. So what I will do is I will come back to this. You just have to click on this Jupyter lab over here or over here. So I will come back to this Jupyter lab, and you can see currently the status is starting. So my application is trying to start. Okay. So we will wait for this application to start, and then we will use the Jupyter notebook to make our training job done, and we will make the credit limit predictor fully on cloud. We'll clean the data fully on cloud. So feeling proud. I hope you also feel proud, because yeah, it's running now. So now the next step would be to open this. Now make sure that if you stop watching this video at some point, you have to stop this particular application. And the best practice would be to also delete this particular application. And next time when you come back, you can create a new Jupyter lab. If you don't do so, you will be spending a lot, which I don't want. Okay. So just make sure you stop it and you delete it once you probably are not able to continue this series, or it is not going to be a very long video. Still, if you are not able to continue, make sure you stop this. Otherwise, it will cost you a lot if you don't care about it, if you come after a month or so. So now if I come over here, you can see I'm on my Jupyter lab, which is like a notebook for you. And wait for some time. The number one thing which I don't like, and which I hope you also won't like, is the fact that this is light theme, and I hate light theme. So I'll just turn it to the Legends theme, which is the dark theme. Once I do that, I can see that currently there is no kernel running. So kernel is like, I hope you know. So we'll go back to the folders option over here, and this will be our default folder. We will create a new notebook over here, guys. So we'll click on this Python IPY kernel, Python 3. So we'll create a new notebook over here, which will be initially named as untitled. I will give a name to this notebook. You can press F2 as well. I will give this name as credit limit analyzer. No, credit limit predictor. AWS or AWS over here. I know. Let's just keep it as it is. Or let's change it. Let's keep it as it is. So before we do anything, you can see over here, we are connected to this Python kernel right over here. So if I click on this again, you can see we are initially connected to Python 3 IPYNB kernel. You can change the kernel according to your requirement. We'll just keep it as it is since we don't want to change it. Now, what we are going to do is we are going to first check whether this Jupyter notebook is actively running or not. I will pass hi, and yeah, that's it. Once this is done, it should print hi. And you can see over here as well, it should show a star once we try to run it. You can either run this from here, or you can press Control Enter. Okay. So as soon as I press Control Enter, you can see initially I got a star, then I got first. Now this 1 means this was the first cell run in this notebook. If I run this cell again, it will show as second. Okay, so it prints high, and that's what I want. Talking about today's session now, we are going to build a model which will predict the credit limit of the user who is trying to create a new account on our platform. For that, we have two data sets, which is our users data and cards data. As this is a cloud platform, I would not recommend, or I would not try to use our Giga file, which is the Giga chat for the complete analysis, which is our transactions file. But you can do that on your side as well if you want. It will highly cost you around 300 to 400 rupees, even if you try to do that, but not recommended because you just have to understand the tech, not the end-to-end project. It's fine if you are working with these two files. The idea would remain the same even if you try to implement it for a transactions file that we have, or you can do something that you can create a sub file for only a particular card brand and do the further analysis on that. Regardless of that, what we are going to do is we are going to set up this for the SageMaker AI, and we are going to write our code. So the number one thing that we are going to do is I'm going to copy paste the code over here. Reason I'm going to copy paste is because first, of course, I don't know how to write each line by myself. It will take a lot of time and not needed, honestly. Secondly, most of the code will be boilerplate code only. Okay. So over here, we are importing the Amazon SageMaker, then Boto3, which is to access the S3 bucket over here, then Pandas, NumPy. Inside SageMaker, I'm also trying to import the sklearn estimator, which is a sklearn library, then IO, import OS, then sklearn model selection, then sklearn processing, and then we are also going to import JSON. And in the end, we are initializing the SageMaker session and rule. Okay, so we are creating the SageMaker session over here. This is like creating an instance of SageMaker, which we created over here. And then we are going to assign the role. We are going to get the role. Basically, we are getting the execution role over here that my user is having. So it will just pass it on the execution role, which is in our case administrator access, so it can use anything. After that, we are setting up the bucket as this bucket over here. Okay guys, so this is a bucket which SageMaker will create. Initially, you will see that we have this random bucket over here, which is a part of my boiler code. But while you create this domain over here, right over here, let me just show you. Inside the admin configuration, you will have your domain. When you create your domain, the Amazon will automatically create a bucket for you, a S3 bucket. Now, what is S3 bucket? S3 bucket is like a database storage system that AWS provides. Why do we need it? Either we can store our data over here only, like we used to do in the projects that we make locally. But once you store your data over here, if I upload the data over here, it will be an elastic storage system, which will cost a lot more than the S3 bucket. Now, this is not your local computer, so make sure everything costs you something. Even the notebook that I've created right now will cost me something. So I have to delete the resources that I create. And using this elastic storage is not a good practice. So that is why we use AWS to store the data. And when we create the domain over here, it will automatically create two buckets, one for the Amazon SageMaker Studio, another one for the Amazon SageMaker AI. We are going to use the bucket for Amazon SageMaker AI. Now, how to know which bucket is for which purpose? It's pretty simple. All you need to do is you need to go back to the search over here and you need to type S3. Once you type S3, it will be something like this and you have to go to this S3 over here. Make sure it's S3 only. You have to go to this management console and you can see we have two buckets which are auto created over here. There is a bucket with some random name like this in the end, and there is a bucket without any random name. And the bucket of our interest will be something which is without this random name. Okay, so what I will do is I'll copy this name over here and you can see this bucket is currently empty. There is nothing inside it. And you can just copy the name over here. And then I will pass that name to this bucket name over here. Once I do that, it will get the name of our S3 bucket from where it will pick the data set, which we are going to upload now before we do the further analysis. But before that, in the end, you can see we are also creating an instance to access the S3 bucket, which is my S3 client. A very simple step still needed. Once this is done, all you need to do is you need to run this code and pray to God that it works. Because if it works for the first time, it's a good sign. Regardless of that, what I'm going to do is I'm going to click Control Enter and I'm going to run this cell, and you can see it shows that star over here. And you can just ignore this over here, and you can see, yeah, it is running. Ignore this. Okay. Add a new cell, and yeah, this cell is executed. The reason it shows 3 over here is because we already executed print high for 2 times. That's why it is the third cell that we are trying to execute. After that, what we are going to do now is that we have set up the credentials for the S3 bucket. We have set up the session for the SageMaker, and we have also initialized the role over here. Now we are going to get the I would call it as our files from the S3 bucket. So we have 2 files over here, which is our cards data and the users data.csv. So what we are going to do now is that we are going to upload these 2 files on cloud on our S3 bucket. So how we are going to do that is we are going to basically set up the path for that. And let me just show you the code only. Just wait a second. Okay, so yeah, I will just quickly put this over here. And you can see over here, it is taking data from this random directory, which is not our directory because we have not put the data over here. So where we are going to put our data, we are going to put our data on S3 bucket. So we'll set that path like this. Okay. So let me just change this to the S3 path. Just a quick second, I would say. Okay, so yeah, that looks good to me. Okay, so what I will do is I will pass the path over here. So here we have this path, and instead of data, we are having users data.csv. And we also have cards data.csv. Okay, it will be users since the data frame name is user over here, and this will be cards data.csv. Cards data.csv. But till now, we are not having any folder like data in our S3 bucket. We don't even have these files over here. So we have to manually upload the files, and then only we can do this thing right over here. Let me just cut this. And I don't know why this shows an error. Regardless of that, what we are going to do is we are going to quickly come to this bucket right over here. And before we upload anything, we create a folder as data, because over here, we are storing this inside the data folder. So what I will do is I'll create a folder as data, keep everything as it is, just create the folder. Once the folder is created, go to that folder and upload the files, which is our cards data.csv and our users data.csv. Now, I assume that you already have installed those files from the data link, from the dataset link that I've given you. So first I will click on the cards data, and then I will add the another CSV file, which is my users data.csv. After you get both of these files, you just need to click on upload, and it will upload these 2 files over here. Coming back to the initial path, which is this one, you can see inside this initial bucket named as SageMaker US East 2 and then some random number. I have this folder as data, and in data folder, I have two files as cards data.csv and users data.csv, which we are going to use for our analysis. After this step, let's take a 1-second break and then we will look on this particular file right over here. Sorry guys, I just took a few seconds break. I just needed to drink some water and yeah. So now we are back. We have assigned the S3 bucket path to the data that we are going to have. And I hope you understand we are having this data folder, and then in that data folder, we are having these two CSV files, and we have created that data folder right over here. In this bucket, you can see this is the data and this is our files. After that, what we need to do is we need to basically merge these two files. Since we have already discussed about this, in our cards data, the user's data ID is working as a foreign key. So we are going to merge these two files on the left join, and this will be basically giving us the card details along with the ID of the user who is using that card and all the details regarding user which was earlier stored in this users.csv file. So now basically we are having everything inside this merge df, which will contain the unique ID as card ID because we have unique cards, which is around 6146. And then we are also going to have the details of the user who is going to have that particular card or who is assigned to that particular card. And yeah, that's it. Now what we are going to do is we are going to drop some columns. Now we don't need ID. We don't need client ID. We don't need card number. We don't need CSV. We don't need the address of the user. We don't need user ID. We don't need longitude, latitude. We don't need cards on dark web as well. So we are going to drop all these columns from the data frame that we have created as merged df. Okay. And then we are going to rename the data frame as cleaned df. Now, why we are trying to delete all these columns? And I hope you understand CVV is not of our use. Card number doesn't make any sense. It will not help us predict the credit limit of the user. Like card number? Seriously? Okay. And why card on dark web? Why are we also removing this? Because if you have watched the analysis of dataset, which I have put in this video as well, and if you have watched that in our other videos, cards on dark web is a column which is always no. So when you have a column which is constant, we will remove it because it will not help us to analyze anything or predict anything. Okay. So we'll just remove that. Once that is done, we will convert the columns into floating numbers. Since the credit limit is of type text, as we have a $sign before the credit limit. Let me just show that to you over here if I can. So I don't know whether I can show you. No, I can just download it. I can't show you. Okay, it doesn't allow me to show it over here. So regardless of that, we have already discussed about that. So credit limit is of type float. I mean of type text. So we'll convert it to type float by basically just removing the $sign over here. It says some error, but don't worry, it will not give any error to us. Okay. So yeah, after that, or I can put a F over here. Oh, I won't. Just don't worry about it. It won't give you an error. Okay. So after that, we have the per capita income as well, which we will convert into a type of float. We will basically remove the $sign and convert it into a floating variable type from the text variable type. Okay. So we'll do it for these four numerical columns over here. And after doing that, we are going to basically first put that in a list, which is money calls. And then we are going to iterate through this money calls using this call as a iterator. And I'm going to pass this inside it over here. And I'm going to replace each instance, or I will say each value with the by removing the $sign and then converting it to as type.float. So it's a pretty basic regular expression conversion, which you can do it on your side as well. After that, we'll also make sure that we convert the expiry year into date time format and also the account open year into date time format. And since we are not going to use this, we'll remove this as well. Though we have changed this because I want to show you how to convert a text into a date time format, which is like you are going to use the toDateTime function, and in which you will pass your expiry and you will pass the format, which is month year or year month or anything like that. Okay. But since expiry year and account opening date is also not a factor to predict the credit limit, we will remove that from the analysis. After that, we'll create some feature engineering. That means we are going to create some features over here, which is like our debt to income ratio. Now, see guys, suppose you are having a debt of 1 crore rupees and your yearly income is just 5,000 or 5 lakh rupees. So you are under a huge debt. But if a person is having an income of 50,000 crores and he is taking a loan of 1 crore, so for him that loan is almost like negligible. So just talking about the debt in itself would not be enough. So what we are going to do is we are going to talk about the ratio of total debt to the yearly income so that we can get a better idea of at what level the person is standing. Okay. So then we have the account age to know the age of the account. And then we have the income per card, which is like yearly income divided by the number of cards that the user is having. So suppose a user is basically having a good yearly income, but he's trying to get a lot of cards. In that case, he might default in future. So we want to make sure what is his income depending on the number of cards that the user is having. Okay, so after doing that, we'll get averaged income on the basis of number of cards that the user is having. So that income will be like income per card. Okay, and then we have this categorical columns over here. We have 4 categorical columns. We have card brand. In total, we have 4 card brand as MasterCard, Visa, Amex, and Discover. Then we have card type as credit, debit, prepaid. We have hash chip, whether a card is having a chip or not. Then we have gender as male and female. After that, we are basically get dummies, and we are just trying to get these card details over here, and we are storing that. We are trying to encode the variables, categorical variables. So instead of having the categorical variable brand, suppose card brand as Visa, MasterCard for Amex and Discover, now we will have the names as 0, 1, 2, 3, and 4. Okay, so machine learning doesn't understand words, it understands numbers. So we are converting everything into numbers. After that, we'll put the features in this column right over here. And we will not put the credit limit in the features because it is our variable of interest. So we'll put that in the Y, whereas all other will be in the X. So now what we are going to do is we are going to simply just use this line. It is a very standard line. I hope you understand. If not, let me tell you. What we are trying to do is we have got the features in X and the, I would say the output which we want, which is our credit limit in the Y, something that we want to predict. So the features are our predictors and the output is our independent feature which we want to predict. Okay, so X train will be our training data, X test will be our testing data, Y train will be our training label, whereas Y test will be our testing label. So we are going to use this train test split function provided by sklearn, and in that also you can see over here. Oh, I forgot I can zoom. Sorry guys. So in that also we are passing the test size as 20. That means I only want my 20% of the total data to be used as test data, whereas remaining 80% of the data will be given to the training part. Why I have put this random state as 42? Because I want every time that this split is always the same. So suppose if you are also running this code on your side, you will also get the same accuracy as I am getting because I am putting this random state as 42. So the data will be splitted in the same way as I am trying to split. Okay. So if I change this to 24, it will be 24. It's just a random number. There is no such significance of what number do you choose. So regardless of that, what now we can do is we can run this code over here. Make sure your data is stored correctly on the S3 bucket and your name of the S3 bucket is correctly assigned. See over here, I've put this space. This can be error. So make sure you check everything. And I have to run the above cell again because of this small issue. So I'll press Control Enter and it will run the cell. After that, I will come down and I will run this cell as well. It will take some time, it will load, and you can see over here, this cell is executed as well. So yeah, now we have transformed the data. We have used a standard scaler as well in order to basically transform the data that we have. which is X and Y. Now, what is standard scaler? What the standard scaler is trying to do, it will try to basically put all the values between the range of -1 and 1. Why do we need to do that? Suppose there is something as credit limit, which is like in the ranges of 10,000 to 50,000, and there is yearly income, which is in the range of 30,000 to 5 lakh. And then there is a age, which is just like from 0 to 100. So because of this uncompatible ranges, we are trying to put everything between -1 and 1 so that it is easier for us to analyze and it will be a good option. So yeah, that is what it is. Our standard scaler, we are first creating an instance and then we are using it to make our transformation, make our features, which is our X train and X test, and that is it. So yeah, what I will do now is I will simply just run this code, which I've already done. And after that, let me just show what is the next step, because again, I have already make sure that I have this code pre-installed in my computer so that I don't get any errors while I work with you guys. Okay. So now what we are going to do is, since we got our updated files over here, as you can see in the third code cell, we have to save the CSV file without headers. Okay. So without header means we are not going to get the header, which is like credit limit or the feature headers that we have. We are going to remove all that. So for the part over here, we are going to put this in the train df, and this will be the test df, which will contain the scaled features that we created right over here. Okay. And after that, we are going to put this in the buffer. That is just a step, guys. Don't worry about it. And then we are going to convert this to a CSV. And we are going to store this CSV, as you can see, s3.client, which we created initially over here, which will help us to access the S3 bucket in this notebook. Okay. So using this S3 client over here, we are trying to put this train.csv and the test.csv. Okay. And once this is done, both of these files are uploaded in this new folder, which is train and test. We will basically also set up the path over here as this, and we will print that path to our end user. And once the job is done, we'll save this file name as scalar file. And yeah, that is it, what we are going to do. So now what I will do is I will quickly just wait, give me a second. Yeah. So what I will do is I'll quickly just run this code over here. And in this code, basically, we are just saving the files in our S3 bucket, our cleaned data to our S3 bucket. So once I run this, you can see a star over here. And yeah, the training data is uploaded to S3 and then the S3 bucket name that we have created. And then the credit limit prediction is like the project that we are working on. In that, we have the folder as train, and in that also, we have the data in the as train.csv, and in the test, we have the data as test.csv. Let's look at that. Let's go back to the buckets over here. We are going to this bucket. Make sure you don't click over here. This is for Amazon SageMaker Studio, whereas this one is for our Jupyter Notebook. So we have this credit limit prediction over here. We have the scalar, we have the test, and we have the train. So we'll go back to the test, and you can see the test data over here, test.csv. We can see the train data over here as train.csv. That is it. That's what we needed to do. Now we will start with our training job, guys. So either you can create your train.py as a separate file, or you can use this notebook to create that file. So let me just run this code over here. Here I'm basically trying to create a new file as train.py, and this is the code that file will contain. So before I show you the code, let me just quickly run this file over here, because it is just creating a new file named as train.py, and then we will see the code inside train.py. So if I run this over here, and you can see over here, just a second. I don't know why it is taking time. Yeah, you can see over here, it is my train.py file, which is having importing this argparse and this OS and a lot of other libraries over here. Then I have this model FN, which is going to basically load the training model. So what happens is, guys, in our SageMaker, we have to load the model. So once your model is done, we have to load that model. We have to store that model. Okay. So in order to do that, we are going to attach this path over here, which is my joblib.load and os.path.join and model directory, in which I will store this path with this name over here. And in the end, I can return this model if we want to use this model for the creation of endpoints. Okay. So basically, in the input function, we are passing a JSON input, which will give us the output as a instance. Okay. So basically, input function is, this is a boiler code. You don't have to worry about it. In almost every kind of a machine learning model, you will use same kind of boiler codes. So what we are trying to do is, we are trying to pass on the test data. And then this input function will basically convert that data into a request content type. And this predict function will be basically model.predict. And yeah, you know what's the game? It is going to predict the output for us, which is in our case, credit limit. So these are the boiler functions, or I would say boiler code template, which you are going to use in almost all of your projects. So it is not something which is like too hard to understand. This is basically definition of the function, which is written over here. Parse the input data for prediction. Load the training model from the model directory. So we have our model directory from which we will load this model. And then yeah, this is our main function. Going in the main function, we are first going to create an instance for this arg parser. And then we are going to add this model directory as the argument inside this environment of our SageMaker. So now this is also a boiler code. Basically, we are creating this model directory where we will store our model and also the training data which we are going to use to train our model. Okay. So this is my SageMaker channel path channel train. Okay. So this is basically a parser that we are trying to use, and we are storing these two things. In the end, we are getting this args from the parser, which is like this arguments which we assigned over here. Now, the reason there is a comma and the underscore over here is because this parser dot parse known argument will give us two values, and we only care about args over here. So for the other, we'll just keep it as underscore, and we just don't want it. Okay. After that, we'll load the training files from this args.train. So as you can see, I'm assigning this as train. So inside the args, I will get from this args, I will get the training data. And for the training data, I will check whether there is any other args.file. So for f in os.list directory inside args.train. So right now we are only having one training file inside our args over here, but maybe there can be more than one training file. So for that, we have to basically use a for loop to check for each file which is ending with .csv, and we have to load that file in this training files. Similarly, for the training data, what we are going to do is we are going to concatenate. Basically, we are just trying to read each of the CSV file, and then we are trying to concatenate it, and basically we are just converting it to a data frame. In the end, we have this X train, and we are going to train data. In the end, we also have the Y train. So we are going to get the labels of that. Okay. And this is our model, which is going to be the random forest regressor. In my case over here, we have n estimators set to 200. We have the max depth set to none. We have min sample split as 2. We have the max feature as square root. We have the random state as 42. Then we are going to fit this model to the training data that we have. And then in the end, we are going to dump this model to this args.model directory, which we created over here into our SageMaker. I hope you understand what we are trying to do. And all of this is done inside this train.py. Once I come back to the notebook which we created, this is what the script of our train.py looks like, and that's how we created it using our notebook. So you can create a separate train.py file all by yourself and put this, or you can use this notebook to create a file for you and put everything inside. Now, I don't want you to feel that you are not doing a lot of things. You might be not able to understand what is going on in this code, because you can use a basic boilerplate, and I've used the same. It is not hard. You can read the code. We have this 3 function. This will load the model. This will take the input and convert it into a pass the input data for a prediction, and after passing, we are passing that input data, which we are returning right over here for predicting the output labels. Okay, so yeah, that is what it is. Now comes the important part. We have to train the model which we created, which is our random forest model. So for that, what we are going to do is, I will be just quickly copy pasting this for you guys, and this is where the important things comes. Entry point will be my training.py. Role will be the role which I have got from here, which will be the role of the person using this. So for the training, it will ask for the role. Suppose you are one who created all of this, and you are not having the that policy of basically training the models. As I've told you initially, we have given the policy as administrator access, so we can do everything. But if you don't have, then you will be not able to train the model on SageMaker. So since we have already given it administrator access, we can use that. Then over here, we have instance type as ML M5 large. Now guys, as we discussed before also, this instance will cost you money. Initially, this notebook was set up on, let me just show you, click on this application. I hope you have the screen on here. It is ML T3 medium, but now this is ML M5 large. So this will cost you more. How much? You can check it on your side. The way to do that is pretty simple. All you need to do is, you need to go on AWS pricing for training jobs on SageMaker AI. So now, once you come over here, you have to click on this machine learning services on this particular Amazon SageMaker AI. You need to come down and you need to click on this training jobs over here. Training. Okay. In that, which model are we using? We are using ML M5 large. Right now, it is not going to cost you something because it is not running. Once you click run, it will cost you the money. Okay, guys. So let me just quickly show you what ML M5 large looks like. So yeah, this is my ML M5 large, and for every hour, it will just cost me $0.115, which is a very less amount, but still it is better than our initial instance that we used, which was pretty cheaper. But for training, it will take a lot of time, so we are going to use this. Then we have the Python version, and then we are passing the SageMaker session, which we created right over here, so that it knows that SageMaker is going to execute this training job, because this training job will be shown. Let me just go back to the SageMaker. Make sure to click on SageMaker AI instead of SageMaker. So over here, we will go to the training jobs in order to see the existing training jobs. So right now, it will load. Right now, you can see inside the training over here, we have, it will always take time to load. So inside the training, you can see over here, we have training jobs. Initially, I have no such training job which is currently executed. That's why it shows completed for the 4 which I created before, and failed for the 1 which I created before. But now, as soon as I press enter, and make sure in the end, it will fit the training data from the S3 training path. And this is my S3 training path, which you can see over here. Okay. So S3 training path. I hope you understand. Look once again, this is the S3 training part. Okay. This is the S3 training part. Okay. So now we will just simply run this. This will take time, guys. So have some patience. It might take from 5 to 6 minutes for this code to get executed. So as soon as I press Ctrl plus enter, see, it has started the execution. If I come back to the Amazon SageMaker AI, in the training jobs, if I try to reload this over here, you can see that it will show you a running training job. Okay. So job status will be running. Wait for some time. It says in progress, and the job secondary status, it's starting. So this is our current training job. coming back over here, it says starting the job, and it will give the, it is basically the logging, which we are going to see in the future. And you can also watch Vikas Das MLOps playlist to understand what is logging. So this is basically logging over here. So he has explained logging in a pretty basic way, and I would highly recommend you to watch his playlist for this. So yeah, it is saying that preparing the instance for the training. So it is basically preparing our ML M5 large instance for us, and it will do all the steps. It will take some time. So once it is up and running, what we are going to do, we are going to see the training model that we got, and then we will create the endpoints which we will use to basically see how the predictor works for the data. Okay. So yeah, as you can see over here, once you try to basically run the code, after a couple of minutes, it will be executed and you will see the status as complete over here. So it took around 3 minutes for us to run this code. So according to that, you will be charged for using this particular instance, which is ML M5 large. Okay. Regardless of that, you can see the logs over here. It basically downloaded the training image download completed, uploading generated training model, and then in the end, training job completed, training seconds 114, billing seconds 114. It's pretty simple. Now after that, since we created our training model, we also want to deploy the endpoints for this particular model over here. So it's a very simple step. We just have to create a predictor and then sklearn estimator.deploy, and that we are going to deploy this on the one instance, which is our ML M5 large. And in the end, we are going to name this endpoint as credit limit endpoint. As soon as I run this code, it will take some time. And then you can see over here, let me just show you that. Wait for a second. It will take some time. Meanwhile, we can come over here and we can go to this inference right over here. In that, you have to click on endpoints. Right now, we currently have this endpoint, which is creating, not created. Okay. So this is our endpoint. Coming back over here, guys, over here, you will see that after some time, not right now, just wait, you will see a underscore. And that underscore, see over here, this underscore shows that currently the endpoint is being created. Once you get the exclamation mark, that exclamatory mark, that means your endpoint is deployed. And then you can test that endpoint. This can take up to 5 to 6 minutes. So you have to again have some patience for the model to be deployed on the Amazon SageMaker. And once it is deployed, you can use it. Right now, the status is creating. Over here also, you can see we have 2 underscores. After some time, once you get the exclamation, it will be up and running. Make sure to not interfere or change anything in this. Just keep it as it is and make sure it is running correctly. Okay. So after it will be executed, this cell, then we will talk about the further analysis. Okay guys, so you can see over here, once our endpoints are being deployed, it will show exclamation sign just like this. And I hope you got the same. If you got some error, make sure to comment down your errors below. We'll try to figure out how to solve those errors. Regardless of that, for most of you guys, you will see something like this. After that, what you need to do is you just need to go back over here and you can see your endpoint is in service. Okay. So under the inference right over here, you can see the endpoints and it is, the status is running. Okay. So after that, coming back to the credit limit notebook over here, what I want to do is I want to predict the credit limit. Since our model is created, since our model is deployed, how to check for the credit limit now. So what we're going to do is we're going to basically test the endpoints and then we are going to see how the model works. So we have the details right over here as it is. You can check this out on your side as well. So these are all the details that we have. This is a sample example that I'm going to pass. Also, we will be looking at the model's accuracy, mean squared error, mean absolute error, and the R squared score, which will help us analyze how well our model performed. Okay. Over here, we are trying to basically serialize the data into a JSON serializer because we are passing the data as JSON instead of CSV. Basic steps, nothing much. we are preparing the data set, and then we are basically, I don't know what was that error. Let me run again. Okay, so yeah, we are getting these things over here. Oh, maybe that would throw an error to us. Maybe that would. Regardless of that, let me just quickly run this code right over here. And as expected, we are getting this error because these things are not defined, guys. We have not defined those things yet. We have not trained the model or to basically tested it. So we have not yet tested it. So I'm going to remove this. This evaluation can be also done over here. We are not going to look about evaluation since we have already deployed the model, and I already know the evaluation, which is like around 0.68 for the R squared, which is like it predicts the 68% of the data correctly. And so yeah, with that note, we'll just run this over here, and we are passing these features in order to predict the credit limit for the person. So 0 means he's a male and he has a chip. Credit type is like he has a credit. The card is of type credit. Card is of type debit, which is 0. And then we have card per brand and the other variables right over here. So card brand is not Visa. It is basically, let me just quickly go through. It is MasterCard. Okay. Card brand is Visa. Sorry. So yeah, after passing all these variables over here, I'm going to just press Control and Enter. These are all my, I would say, all my features which I'm passing, and in the end, I'm getting the credit limit as 15,475, which is around 15,500. So suppose you are a bank and you want to assign a credit limit to a user. Every time you're not going to check everything by your side. You have to make a system to do so. So this is a very small project, but imagine guys, you're working in a bank and you have all these data sets. You can make a fraud detection system. You can make a control system with a lot of other variables by adding those variables to our analysis. Right now, we had very basic variables like yearly income, credit limit, or I would say yearly income, credit score, and then per capita income, things like that. But in the future, when you are going to work with a larger organization, they might have a lot of data and you will be having an amazing team to work with. So just guess, you are going to work on a live project, which will be somewhat like this only, where your end goal was to predict the credit limit for a credit card that you are going to assign. To be on the safe side, yeah, that's how you do it. So that was it for today's video. Before you end this video, I also want to tell you guys that it is everything that you need to do for this video. This was it. But still, the last and the most important part is still remaining. Because if you close this window right now as it is, after 1 month, you will probably speak bad words in my comment section that I got some bill on my AWS cloud. So make sure to delete this endpoint which you have created. So what I will do is I will go back to this notebook over here, and I will just simply do one line over here, which is delete the endpoint, and that is it. Before that, let me try to see what is the effect of using the gender as female. Okay, right now it is as male. So what I'll do is I'll convert it to female. Okay, I hope it is not something controversial. Let's just test that over here. And it is again the same, I guess. Oh, it has to be 1. Okay, so yeah, let me just run this over here. And now it is almost the same. So yeah, I guess that is not an issue. Let me change the number of cards to 1 only and then try to analyze it. This time the credit limit is somewhat different. Okay, so maybe current age can be a factor. Let's change the current age to let's say 22, then try to analyze it. Now the credit limit has reduced. Okay, so like that you can try it on your side. I will put the code in the description. You can download the whole file, which is my IPYNB, as a IPYNB file, and then you can follow the step which we did on the cloud platform. I'll provide the GitHub link in the description from where you can get it. Okay, regardless of that, we have to delete the endpoint. So for that, we will do predictor.delete endpoint, and we'll just press Control and Enter, and it will delete the endpoint. Wait for some time, let it delete the endpoint before you click on this. Okay, so wait for some time, let me wait as well. And coming back to this inference over here, going back to the endpoints, you can see we don't have any endpoints now. That means the endpoint was deleting endpoint with the name credit limit endpoint. So now you can safely close this, but remain here only, because guys, even if you are not using this notebook right now, also your kernel is active and this notebook is active. So make sure you delete this notebook. But before that, I'm gonna save this notebook as it is, and yeah, it is done. It is saved perfectly. I'm gonna save this again, and then what I'm gonna do is I'm going to download this notebook over here. So I'm gonna go to this, just a second. I'm gonna click over here and I'm gonna download this so that I can put it on my GitHub. And yeah, after doing that, what I'm gonna do is I'm gonna delete this notebook. So I will just click on this notebook and press delete. Make sure you delete everything, which is our scalar job.lib as well as our ipynb, our train.py. After that, you can also go to this right over here, and you can see there is no current service activated. You can safely exit out of this. But over here also, you can see once you go back to your Jupyter lab over here, the application is still running, which is not a good sign. You have to stop it. So click on the stop, make sure it is stopped, and wait for some time until it is stopped. Again, you can click on run and use it. Otherwise, you can create a new Jupyter lab space and use that. So for now, I'm going to click on this and I'm going to delete this space right over here. Click on these three buttons and click on the delete. I confirm I want to delete this space. Okay. So yeah, click on delete and it will be deleted automatically. So now you can safely exit this as well. Now do one more thing, go back to your domains over here and make sure that you delete the domain over here as well. But before you delete the domain, we have to delete the user which is inside this domain right over here. So we'll go back to the users over here and we're going to click on this user and we are going to delete this particular user. So we're going to click on this delete button right over here. We're going to click on yes, delete, and then we are going to type delete and delete the current user inside the domain. Once we are done with that, we'll go to domain settings over here and you can see there is an option to delete the domain right over here. You won't see this option unless you delete your user inside the domain. Click on this domain over here. Yes, delete my domain, and then again do the same steps. It will take some time. Come back to the domains right over here and you can see the domain is basically deleted. Go back to the inference and check the endpoints over here and you can see the endpoint is also deleted. Inside our models, as I've told you, SageMaker will create its own model directory. Over here, this was the model which we created today at 5:51 on 15th of April 2025. So make sure that we try to delete this as well. Although it is fine if you don't delete it, it will not take a lot of space. Still, a great advice to delete your models after you use it. So click on the models and delete if you want. Regardless of that, coming back to the training job, here we can see the training job which we done. It will show you that it is completed. We don't have to delete it. If you want, you can just come over here and yeah, it doesn't matter if you delete it or not. It will not cost you anything. Coming back to the domains over here, you can see we have no active domain. Coming back to the endpoints over here, we have no active endpoints. And yeah, that's how you safely make sure that after your projects, it will not cost you anything. But till now also, we have some other things in our S3 bucket. So going back to our S3 bucket over here, I can delete the data as well. So as I've told you, while you create a domain, S3 bucket will, the SageMaker will automatically create two S3 bucket, one for the studio and one for the SageMaker itself. When I click on the SageMaker, it will have the details over here. Inside the SageMaker, you can see we have the output as our model, which is our machine learning model. You can download it if you want, or you can just delete it. So I will click on it over here. I will delete it. I have to type permanently delete. So I'll just copy it from here and then I will type it and I will delete it. Like that, you have to individually delete everything. And that's how you make sure that it will not cost you anything in the end. And yeah, now I click on these 3 at a time. And if I try to, let's say, delete it, it will, just a second. So it will successfully delete that as well. Coming out of it, now I will delete my credit limit predictor as well as data folder as well. I will go to delete and then I will pass permanently delete to delete these as well. Once this is deleted, I am basically having an empty file. So if I click on this empty bucket, I can now delete this whole bucket. Make sure you have to pass the complete name of the bucket. Just copy it from here and paste it over here, and tada, you have deleted it. Once it is deleted, we have this other S3 bucket as well, which is already empty. So you just need to copy the name of this bucket and press delete button, which I will do right over here. Coming back to the buckets, click over here, press delete, and then delete this bucket by passing the name of it. And yeah, you are done with that. So now S3 bucket, we don't have any bucket. And for the SageMaker AI, make sure you don't have any active domain and you don't have any active endpoints. That is it for this video, guys. I hope you really enjoyed everything we've done in this video. We tried to explore Amazon SageMaker AI, which was really amazing. We can do a lot more in this. We can use Lambda function, which is the scope for the future. We can create APIs, which we can then use in our applications. But this is all for the future episodes. For now, that was it for the general overview of this beautiful platform provided by Amazon Web Services. So yeah, that is it for this video. Have a nice, beautiful, and a healthier day. And yeah, bye-bye.